Hello all. Today, let us see in detail about LERS decision rules. So what exactly is this LERS? LERS is expanded as learning from examples based on rough sets. It's the baseline of an LERS would be that LERS gives out a certain set of rules which can be applied over an example, and these rules are obtained from a previous example over which LERS has been applied. So these LERS rules are in general very generalized and they are not data specific. The reason for it to be so is that it can adapt to many number of examples and not a certain specific data sets. To be precise, there is an example and we apply LERs over it. It gives us certain decision rules, and these decision rules can be applied over another example and so on. So the reason for it to being generalized is also a fact because different kinds of data set are used in the similar cycle. So now let us see a few applications of the LERS. The LERS has a lot of scope, and a few examples where it is applied are financial department, the medical industry, and the military domain. For example, in the financial department, say if there is a user who is in need of a loan, the LERS decision rules can be used to come to a decisive conclusion if the user is qualified for a loan or not. In the medical industry, it supports for diagnosing the patients. And in the military industry, to keep track of the candidate's performance, these decision rules can be used as metrics. In general, the machine learning and data mining system LERS is universally accessible and has a lot of potential for scope of growth. One prominent example would be the application and the usage of LERS in the NASA Johnson Space Center, and they use it as a tool to develop expert systems as well. So this is one prominent example. Now let us see how the LERS handles the inconsistencies. The LERS handles the inconsistencies using rough set theory. The main advantage of using the rough set theory is that it does not have to know the preliminary or the additional information beforehand. In the rough set theory approach, the inconsistencies are not removed, and instead it approximates to the lower and upper bound of the data. To be more clear, say we have a data whose graph is inconsistent and goes like this. So what the rough set does is that it approximates to the lower bound and the upper bound of the data and then generates rules based on these approximations. And so we have two types of rules generated, which will be the certain rules and the possible rules. Let us see in detail regarding the rough sets down the presentation.
Hi, I'm Shravani Kalangi and I'll be presenting rough set theory in KDT. So, first of all, let's understand the stages involved in the knowledge discovery in databases. The first step being the data selection. This is where the most relevant data from the huge data set is picked and all the redundant data or the data that is not useful is left out. The second stage being the cleaning process, it is where we remove all the obvious flaws in the data is collected. In the third part, we prepare the data such that it is good to go for the data mining algorithms. In the data mining process, the actual inference takes place. That is where we get the insights of the data. In the reporting process, we make sure to report all of the insights, the inferences that we picked from the dataset, and display it in a visually attractive way. Rough set theory constitutes a sound basis for KDT. First, let's understand what are rough sets. Rough set theory is a mathematical formalism for representing uncertainty that can be considered an extension of the classical set theory. Okay, you might be wondering what is this classical set theory? So in classical set theory, a, a set is either there or not there as part of the observation. But in rough set, we are not giving zeros or ones. We are giving a probability that it might be there in such dominance, or it might be there with this much less significance. Okay. You might be wondering why we're learning subsets. So, data contained in the databases of the real world were never collected with learning kept in mind. All of this data is uncertain in nature, it is indeterministic, and contains noise due to errors in either measurements or during the data transfer, or even the human errors performed during the data collection process. All of these characteristics presented contribute to the uncertainty of the data. Rough sets offer useful tools for discovering patterns hidden in data in many aspects, like the attribute selection, the attribute extraction, the data reduction, decision rule generation, and pattern extraction, which could be either templates or association rules. Uh, a few more details about how this is done. So there are two different kinds of knowledge representations as part of the rough set analysis. One being the information systems and two being the decision systems. A rough set can be categorized numerically by the coefficient of accuracy of approximation. Here, uh, the here these lines denote the cardinality of the set, and alpha b of x defines the accuracy of approximation. In the case of rough sets, the notion of membership is different. Uh, it the rough membership function quantifies the degree of relative overlap between the set and the equivalence classes to which a particular uh, feature X belongs to. Here, the mu X of B states the ratio of membership. So it could be any value between 0 and 1, and the mu X is defined or derived using the following formula. That's it from my side. Thank you.
Hello, I am Radhireddy Curry and my student ID is 8012372215. In this presentation, I am going to solve a problem on LERS. From the given table on the left hand side, we are going to find all the certain rules and possible rules by describing G in terms of A, F and C. Here, x1 to x6 are 6 objects. A, F, G, C are attributes and A1, A2, F1, F2 and so on are properties. G is going to be our decision attribute as we are going to describe G. X2 and X4 objects have the property G1. This is represented as shown in the table on the right hand side. G1 star is equal to set of objects X2 and X4. Similarly, we write the same for other properties. In the loop 1, we are going to write the certain rules and possible rules. In this case, we only have possible rules but not certain rules because none of A1, A2, F1, F2, C1, C2 are subsets of G1 or G2 or G3. Hence, we consider A1, A2, F1, F2, C1, C2 to be unmarked and write possible rules for the unmarked properties. For A1 implies G1, that is, we find the probability of occurrences of A1 and G1. In the first table, as we can see, A1 and G1 occurred together 2 times and frequency of G1 is 4. Hence, support is equal to 2 and confidence is equal to 2 by 4, that is 50%. Similarly, we calculate support and confidence for other rules. In loop 2, we take unmarked sets from loop 1 and generate rules by combining two element sets. The common object between A1 and F1 is X4, and the common objects between A1, F2 are X2, X3 and X6. Similarly, we write sets for other properties. Now these sets are checked with G1 and G2 sets if any of them are subsets. We observe that the set A1 F1 is subset of G1. Now A1 F1 implies G1 is marked and confidence is calculated and found out to be 100%. That means probability of occurrence of G1 property in an object where A1 and F1 occurs is 1. Similarly, we found out that A2 F1 implies G3 and A2 F2 implies G2 are also certain rules. Now we find all the possible rules for the unmarked sets and find support and confidence as already discussed. We continue with our next loops until we don't find any unmarked sets describing G. In loop 3, as we can see, the intersection of A1, F1 and C2 is X4, which is already marked in loop 2. Hence, we are left with two sets, A1, F2, C1 and A1, F2, C2. And certain rules and possible rules have been formulated as follows. We stop at loop 3 because there are no attributes left to be described in terms of G. Thank you.
Hello everyone, this is Dinesh and I am going to take over the LARS example section. And coming to this, learning is based on establishing similarities between positive examples representing the same concept and dissimilarities between the positive and negative examples and representing other concepts. Thus, the task is to include in the description of the concept all positive examples from the concept and to exclude the description of the complementary set containing all the negative examples. And there are several applications using that work on the LARS principle. And one of the main applications is LARS is used in economic and financial prediction. The application in economic and financial prediction can be divided into three main areas. That is business value prediction, database marketing, and financial investment. Coming to business value prediction, it is a scientific field in which many academic and professional people are interested. Financial organizations such as banks, credit institutes, clients, etc. need these predictions for evaluating firms in which they have an interest. A large number of methods such as discriminant analysis, logic analysis, probability analysis, and recursive partitioning algorithm have applied to model this program. And coming to database marketing, in database marketing can be identified as a method of analyzing customer data to look for patterns among existing preferences and to use these patterns for more target selection of customers. To this end, several different problem specifications can be investigated. These include market segmentation, cross-sell prediction, response modeling, customer valuation, and market basket analysis. And coming to financial investment, the building trading systems on S&P index was one of the major applications in financial investment. And especially in medical sciences, LAR is used in sensitivity and specific analysis. Especially in sensitivity and specific analysis, most diagnoses and treatments in medical science are imprecise and accompanied by rate of error. The meaningless of sensitivity, specificity, and accuracy measures used to evaluate data mining applications. Using of LARS is able to circumvent the limitation with its ability to handle imprecise and uncertain data. Poor physical formulae or equations for characterizing medical data. Other physical sciences mainly observe and collect data that can fit into formulae reasonably and solve for the characteristics or relationships of the data. However, the medical data is less amenable to such formulae unless we employ a number of initial assumptions and constant settings. LERS offers a schematic approach for analyzing data without initial assumptions. And coming to prior setting, the LERS approach takes advantage of correct proven philosophy to work with the medical data without a strong prioritized reasoning. Theoretically, statistical clinical trials use predetermined hypotheses and a priori assumptions in the initial hypothesis test design. These also usually require a perfectly random statistical distribution. And LARS concept is mainly used in military. Coming to performance evaluation, it's used in performance evaluation to report the performance of the proposed integrated method, both on original and reduced military simulation datasets, and compare the performance with other state-of-the-art classifiers. And it's used in military simulation analysis. The goal of the military data analysis is to predict the unknown value of shooting rate, such as a low or high. More specifically, military simulation data analysis process can be modeled as a classification problem. A typical military dataset is sparse compared to a traditional classification dataset. It usually contains small samples but with many features. This kind of sparseness often descends the performance of some classifiers. To improve the classification rate, one can remove the irrelevant or redundant feature. And coming to military simulation processing, the performance of integrated method is evaluated on countermeasure simulation data of tank information, which was exercised on medium under undulating ground, hills, and Taiwan Highland for digital armored battalion simulation system. And apart from these applications, it's also used in other applications such as it's used in power system and other industries for fault diagnosis and used for remote sensing image processing. It's used in detecting to detect and avoid intrusion. It's used to detect and filter the spam emails. Even in neural network algorithm, it is used to pre-process data for improving the convergence speed of neural network. Thank you.
Hi, this is Satish and I will be presenting about RoughSet Exploration System. What actually is RSES? Basically, RoughSet Exploration System is a software tool which allows us to analyze tabular datasets using various methods, which are in particular based on RoughSet theory. As discussed, its main aim is to perform experiments on tabular datasets. Few capabilities of RSES systems are it can import data from text files and it helps in data visualization and pre-processing, including methods for discretization and missing value completion. It is also capable of construction and implementation of classifiers for small and large datasets as well as evaluation methods for classifiers. The system has an easy to use interface with a bunch of methods that helps to perform complex and significant experiments in data exploration using RoughSet methods. This software system is a freely available toolset for data exploration, classification support, and knowledge discovery. A brief explanation of the algorithm methods used by RSES are discussed below, where many of these RSES methods have originated from RoughSet theory.
Everything in this digital world is represented in OOPS methodology. Similarly, RSES is also a tool where these objects are used, and there are several ways to represent the object of RSES, which are classified as tables, reduced sets, rule sets, and cut sets. So, in the queue of objects of RSES, the very first object which came in the place are the tables. So, table is no new term in the computer science. It has long been used in the DBMS, data warehousing, and many of its type. So, it contains various functionalities such as load, save as, view, change name, remove. But these are not the only functionalities on which table has been referred to, but these are the very basic and very naive functionality for defining the table. So in the queue, the very first type of functionality comes the load. Load is used to load the data from any of the file format, whether the file format is in RSES format, Vega, Rosetta, or any of its subtype. Next functionality which came in the queue is save as. Save as used to save the table data in the permanent drive or the hard drive. The next command which came, the next functionality which came in the queue is view. So view is basically a type of functionality which is used to view the information of the table in front of the user, irrespective of the fact where the data has been stored. The next functionality which came in the queue is the change name. Change name is just an straightforward functionality to change the name of the table, whether it's in permanent drive or in temporary one. And very last functionality which we are discussing right now is the remove. Remove is basically used to remove the attributes of the table or the whole table from the data. Remove can be used both as in removing data from the temporary table which are or the table which are stored in a permanent databases. So next in the list of object came reduct set. Reduct set are basically used for preventing the redundant information and grouping the attributes in such a way that grouping can be distinguished and in the various format, and there might not be any type of redundant grouping. So the very basic and very brute commands are view, change name, remove, filter, shorten. So view is same as table which is used to view the attributes and data of the sets. The next command which came in the queue is change name, which is as straightforward as table object which used to change the name of the existing sets in the temporary as well as permanent memory. The next command which came in the queue is remove. Remove is basically used to remove the type of attribute, the type of set or the type of subset from the data as well as whole of the sets from the data. The next command which came in the queue is filter. Filter is basically used to filter the reduct set on the basis of stability coefficient, and that particular coefficient has been decided upon the statistics of the whole set. The last command which came into the queue is shorten. Shorten is basically used to cut the reduct set according to the aggressive value. Aggressive value has been termed by some stability coefficient through which the shorten commands work. So the next object which came in the queue are rule sets. Set might same as the cut set and the functionality might sound as the same, but they are pretty different. Rule set basically give the priority on the basis of decision tree. Whenever we allocate some data to the decision tree based on its decision label used to allocate some rules according to which classes has been splitted. So according to that, rule set used to work. The functionality are same as the cut sets, but the inner working and methodology of the functionality are the different. In which view, which is same as cut set, used to view the data in front of the user. Similarly, change name is used to change the name of the set. Similarly, remove is also as same as cut sets, which is used to remove the redundant data from the rule sets. Next functionality which came in the queue is filter. Filter used to remove the reduct data from the sets based on the type of decision in which the decision train has been trained. The next functionality which came in the queue is shorten. Shorten used to shorten the data set as well as the sets on the basis of decision level and might use the technique such as pruning to remove the redundant data from the set. So the next functionality came in the object queue of RSES data types are the cut set. So cut sets may sound the same as the above two set, but these are pretty different and these are limited to only these types of functionalities. according to RSES 1.1. So the very basic functionality in the cut sets are view. These are basically used to view the data in front of the user, irrespective of the fact that whether a set has been saved to local as well as permanent drive. The next functionality which came in the cut set is the change name. Change name is basically used to change the name of the sets which has been splitted into the various parts. The next functionality which came into the queue is remove. Remove is used to remove the particular set from the data. Next functionality which came in the queue is save as. So basically how the cut set work, it used to cut the information on the basis of the interval. Suppose if anything has been proclaimed in a certain interval, suppose if a task has been started at the time 1 and ended at the time 10, on the second task which has been started at the time 5 and ended at the time 10, so it will cut the set into the two of its type, that is 1 to 5 and 5 to 10, and the interval in 1 to 5 there is only one task, that is task 1, and in interval 5 to 10 there will be two tasks. So in the way it used to save the cut set, and according to this only it used to perform. The next functionality which come into this set other type is known as load. Load is basically used to load the set into the data, and if the user want, then this new loaded set can be added to the existing set, which can be splitted into the further set in harmony of the pre-existing sets. So the next functionality came in the object queue of RSES.
Hi everyone. RSES is a freely available software system toolset for analyzing tabular data sets utilizing various methods. So I'm here to discuss about the different data analysis methods in RSES. During the knowledge discovery process, first, the data is loaded into the system, and then pre-processing of the data is done. So once the data is loaded, it is very much important to pre-process the data to remove any discrepancies or any missing data. And then the interpretation or the evaluation of the discovered knowledge is being made. Missing value completion, discretization, linear combination are all the methods that come under the pre-processing of the data. Missing value completion. First, what is a missing value? It is just a data that is not either collected or that the attribute is not applicable in that specific case. For example, a child annual income. So RSES offers 4 different approaches to issue this missing value. Missing value could be represented as a missing or null or a question mark. So coming to the example of the missing value completion, we see that this example has 4 objects and there are 5 attributes: temperature, headache, cough, catarrh, and disease. The first object, we see that all the data is available and there is no missing data. But when we come to the second object, we see that the headache value is missing. So the first approach of RSES says that we could just remove this complete object from evaluation, or the second approach says that we replace or complete the missing data with the main or the commonmost value. The third approach says that we could disregard this object during the reduct or the rule calculation. And the fourth approach says that we could treat this missing value as valid information, as we treat 7, 3, or 1. Cuts, discretization, and grouping. So we generate cuts and decompose the attributes, or we group the nominal attributes using 2 different methods, which is local discretization method or global discretization method. The main difference between the local discretization or the global discretization method is local is inclusive of the symbolic attributes. Whenever there's an attribute on which we want to cut, And that being of a type symbolic, we have to use a local method because global is not valid. Coming to the example, we see that temperature being an attribute of type numeric, and there is a one cut that is made, and it divides it into two intervals, that is an interval which is less than 38.5 and the other interval which includes 38.5 or greater. In the second example, we see that cuff being an attribute of type symbolic, this divides into two subsets. The first subset will have missing and no, and the other subset will have any other values that cuff takes other than missing and no. And all these culls are stored in the file extension .cut. The third method, linear combinations. Linear combinations makes it possible to add a new attribute to the decisions table. So this new attribute could be a derived attribute that is formulated from using the existing attributes. And all the linear combinations are stored in the file with an extension of .dir. In this example, we see that there are three linear combinations, that is, three directions. Coming to the first row, it says that temperature into 0.707 plus headache to 0.707 would lead us to a new derived attribute. The fourth method, reducts and the decision rules. Reducts are often the attributes that could be removed and still they conserve the same properties of the original data. This method is used by RSCS to identify any discrepancies in the data. All the reducts are stored in the RSCS file with an extension of .red. In this example, we see that there are 5 reducts and each description of each reduct is disclosed in between the flower braces and a number preceding it. The number represents the positive region. In this first row, we see that our reduct contains two attributes, temperature and headache. The value of the positive region being 1.0 means that the reduced table with the original decision attribute added is consistent and it has no discrepancies. Decision rules. These make it possible to classify the objects, that is, assign the value of the decision attribute. All the decision rules are stored in RSCS file with an extension of .rul. In this example, there are 16 rules and 4 decision values. The decision values are angina, influenza, cold, and healthy. All these decision values are determined by the conditional probability of the rules, that is like very similar to if and then cases. So the first rule says that if there is a patient who is having a temperature of 38.7, that's a mild fever, and a headache of 7, it would determine that the sickness is identified as angina and that there is only one case that supports this rule. The support is usually determined in the square bracket. By support, we understand that the projects in the training data that match the conditional part of the rule. In the last example, it says that whenever the CATRA is no, the disease that is identified is angina, cold, or healthy, and the total support is determined as 3.
Hello everyone, I am Sakshi, and next we will be discussing the last 4 data analysis methods in the rough set exploration system. So the 4 methods are data decomposition, KNN classifiers, LTF classifier, and the last method is cross-validation method. Data decomposition. Data decomposition tree is a special form of classifier in which the subsets of data in the leaves of decomposition tree are used for calculation of the decision rules. Data in the leaf is selected by the algorithm in a way that all objects it contains belongs to the same decision class. This set of objects is used to generate rules. Here we have an example of a data decomposition tree. As you can see, the data is divided into many different levels, which is also known as leaves, and the data in each leaf is similar, and this is what will be used to generate the decision rules. Next, we have the KNN classifiers. So KNN, which is also known as K-nearest neighbor, is a classification method that does not require a separate training set. So necessary steps such as initialization and parameter setting are done at the beginning of the classification test. So, to classify objects, user only has to invoke the classification/test table button from the tables menu. A user must have a non-empty table object that will be used as a training sample. The algorithm constructs a distance measure based on a training sample. Then, for each object in the tested sample, a decision is made based on how far the training object is to the tested one. This is a visualization of what a KNN classifier is. Here you can see the test sample is divided into many clusters, and this is based on the training sample, and essentially how far the tested sample is from the training sample. Next, we will be discussing the LTF classifier. LTFC is based on artificial neural network architecture. It is a training process based on slight alterations of network structure and parameters made after the presentation of each training object. So the 4 alterations include coordinates for the center of Gaussian functions, correcting the width of Gaussian function for each hidden neuron and each component of the input independently, adding new neuron to hidden layer, removing redundant neurons from hidden layer. The last method is the cross-validation method. The dataset is first split into several equal in size disjoint parts. Then one of the parts is taken as training sample, and the remainder, which is the sum of all parts, becomes the test sample. The classifier is constructed with the use of training sample, and its performance is checked on the test sample. These steps are repeated as many times as there are data parts, so that each of the parts is used as a training set once. The result is the average of scores from the previous step. Here is what the result of a cross-validation method will look like.